Hi everybody, I'm going to include in this video pages 84, 85, 86, and 87, the practice test and the more review. You can watch this video whenever you need to. All right, so number one here, sketch the 8th and 9th pictures of the pattern. So we have the first 7 pictures, 1, 2, 3, 4, 5, 6, 7. It looks like they're adding a segment every time. So the next one is going to have this side added here. And then the stuff in the inside is going to all still be there. And that is that. There's the 8th, and then the 9th one's going to add a side around the bottom. And then all the stuff on the inside is going to be the same. So that is a picture pattern. All right. Number 2, write the next 2 numbers in the pattern and describe it in words. So 1, 4, 10, 22. Let's just look at what the increase. This is up by 3, then up by 6, then up by 12. Oh, it looks like the increase is doubling. The increase, is doubling every time. So the next one's going to go plus 24. 22 plus 24 is 46. 24 doubled is 48. It's going to go up by 48. 46 plus 48 is 94. All right, next one, ooh, fraction. We love fractions, right? Let's look at the top numbers and the bottom numbers and see if we got a pattern there. The top numbers look like squares. These are all perfect squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. So the top is perfect squares. So the next 2 tops are going to be 6 squared, which is 36. And 7 squared, which is 49. I'm just going to use the line there as my fraction line for my numerator and denominator. The denominators, 3, 9, 19. Let's see what those are going up by. 3 to 9, that's plus 6. 9 to 19 is plus 10. 19 to 33, if I subtracted those, that'd be 14 apart. And then these are 18 apart. Looks like the denominator at the bottom is going up 4 more each increase. So the next increase will be plus 22. 51 plus 22 is 73. And then 22, 4 more than that is plus 26. That's going to take you to 99. So these are the 36 over 73 and 49 over 99. So, I mean, the patterns are there. Just got to look at them carefully. All right, next we move to number 3, fill in the reasons. Let's solve the equation and show your work and fill in the reasons for each step. So first reason, get your easy point given. So let's see. So I'd have 2x minus 14. I'm going to use the distributive property. Negative 35 plus 5x. Distribute. All right, next thing I'm going to do is I'm going to subtract 2x from both sides. So my work is going to be negative 14 equals negative 35 plus 7x. Now, that was subtraction. Since I subtracted the same thing from both sides. Now I'm going to add 35 to both sides. So I'm going to do addition. And I could have drawn a line right here. I didn't. All right. This is going to be positive 21 equals 7x. I'm going to finish with division. There it is. Given, distribute, subtraction, addition, division. All right. You could have gone in a slightly different order, but more than likely these 2 steps are either going to be addition or subtraction right here after you distribute. And division is a lot of times the last step when you're solving an equation. All right. In this picture, we got a couple of 90-degree boxes. The 70 is going to allow us to get A because we have a 90-degree box over here. So if we do 90 minus 70, A is 20 degrees. Now we do have some lines that cross, so we might have, we got some vertical angles. The 70 up there is the same as angle D. Okay. We also have some linear pairs. D and E have to add up to 180. So if I do 180 minus 70, I'd get 110, and that would be E. So look for stuff that makes straight lines. Look for vertical angles. In this case, we have some stuff that's complementary as well. Now, the other complementary thing is A and B. That's the other 90-degree box, this kind of sideways one, a little bit, the tilted one. So 90 minus 20 would put a 70 in angle B as well. And then angle C would have to be another 20. Angle C would have to be another 20 because B and C have to add up to 90. So 20 degrees right there. C would be 90 minus, B is 90 minus 20, and C is 90 minus 70. 20, 70, 20, 70, 110. All right, moving down to number 5. So we got linear pairs and vertical angles in this picture. We just have to look at where our variables are and to decide where to set this up. So I look at x's here and here. Those are going to be in a linear pair format. So this is what I'm going to set up to get x. 21x minus 3 plus 5x plus 1 equals 180. So get my x's together, 26x. Negative 3 and 1 add up to negative 2. So notice I didn't do any inverse operations. I just have to combine like terms. When I have that set up, add 2 and divide by 26. 26x equals 182. Divide by 26, and you get 7. Really? Yeah, 7. I don't trust my own math here. X equals 7. Now, we don't have to plug this back in because it just says find x and y in each figure. But if we wanted to plug that x equals 7 in, maybe we could find a shorter way to get our y answer. Because I look over here, and I'm like, that's a pretty easy algebra for my y. Let's do 5 times 7 plus 1. That's going to give us 36 degrees right here. And then that's a lot easier to get my y. I'll use vertical angles and just say 4y equals 36. And all I have to do is divide by 4, and I've got my y answer. Don't know why it's not writing. Y is equal to 9. X is equal to 7. Okay, so it didn't say we had to plug it back in, but plugging it back in is never really a bad idea. It can get us some shorter work to do. Otherwise, to get y, we would have had to done another linear pair, another add these together equal 180 situation. All right, looking over at B. So here are my x's in these locations. They're already in vertical angle locations, so those are equal to each other. So I'm going to set 7x equals 5x plus 18 to get x. Subtract 5x from both sides. Get 2x equals 18. Divide by 2. Get x equals 9. Now, this one, I could just do my y's using vertical angle setup. I could also, substitute my x value in and use linear pairs. But I'm going to, vertical angles I like, so I'm just going to go 16y minus 27 equals 13y. Now, you'd be tempted to move the 13y, but I'm going to move the 16y. Since that 13y is already by itself. Negative 27 equals negative 3y. Divide by negative 3. So I used vertical angles twice in this one. So x and y are the same value. That's kind of unique, but it won't happen all the time. Like in letter A, x and y were different. In this case, x and y are the same. All right, going to the next page. So we got some true falses. So we have to read these statements and see if they exist in the picture. If we can see they exist in the picture, we say true. If we don't see them existing in the picture, we say false. So we got a little box. That's kind of what the picture is. Nice little kind of cube, if you will. All sides are squares. That might be important because squares always have 90-degree corners. So if we make a statement here about a right angle, it might be true. So angle hag and angle bag are complementary. Where's angle hag? Angle hag is over here on the left side, and so is angle bag. Together they make this A corner on the right side of the cube, and since these are all squares, this one's going to be true. All right, this one's going to be true. since there's all these sides are squares. So we've got a plentiful amount of 90-degree angles. Plane FEH, that would be the bottom. We look for 3 letters. Yes, the bottom has 4 corners, but we only need 3 to name the plane. And is perpendicular to plane AHG. That's kind of the right side. Is the bottom perpendicular to the right side of this box? And if it's a box and all these are squares, then this one's true also. Okay, this one's true also. Angle ABG is a right angle. ABG. ABG, if we follow it, goes out to here. It's this angle back here by letter B. It's on the right side again. And if these are all squares, this word square here gives us a lot of 90-degree stuff. Earlier in this unit, we had some 90-degree ones that we said false to because we weren't guaranteed that they were 90 degrees. But having squares does a lot to give us 90-degree angles. Angle CDA and angle DAB are supplementary. Do they add up to 180? Where are these angles? CDA. So CDA is kind of on the top of the box. Erase some of my work there. CDA, if we follow it around, it's this angle on the top of the box. And angle DAB, D-A-B, is also on the top of the box. It's the one over by A. And they're both marked 90, so they would add up to 180. Okay, true. And the last statement, is CD perpendicular to line FG? FG. Now, line FG is in the back bottom. So this line back here, and CD is up on the top corner. Those 2 lines don't cross at all. This one's false. They don't cross at all. Okay, we'll keep moving here. Which ones are matching up? So match a property the same. Symmetric, that's the one where we flip left and right. That would be D, that D. That's where they flip left and right. A, B, B, A. Reflexive property. Reflexive property just says something's equal to itself. That's letter C. Happens to be segments. Transitive property, that's got to have a link, kind of a linking 3 things together. And that's going to be E. X is equal to Y. Y is equal to Z. There's your link. Get rid of the link and say X is equal to Z. Distributive property, that gets rid of parentheses. The A is the only one with parentheses here. And addition property is the only one that's left is B. AT is equal to RS. Notice we're adding the same thing to both sides. That's B. Okay? DCEAB. And finally, we got the proof. We've got reasons down there. This one's only got 4 steps. What do we got going on here? We got a supplementary pair, and that's usually the given. So use your first given up. This one only has 1 given. Where are these angles they're talking about? QRS. QRS is right here. And PSR. PSR is right there. So they're kind of left and right of each other. So we know they add up to 180. All right. In letter B, it says these 2 angles are a linear pair. So if we're introducing a word, we most likely fit the definition of that word. Okay. So that's what this one is. Definition of linear pair. So where are these angles? QRS, that's the same one here. And QRL is over here on the other side. Okay. Yeah, those make a linear pair. They're on 2 different sides of QR. Now, then we go same 2 angles in C, and we go from the word linear pair to the word supplementary. That's not definition of linear pair. Definition of linear pair says how we can draw them, but that's the linear pair postulate. Linear pairs are supplementary. And then we finish it with letter D here, congruent supplements. So this is the link, C to A. QRS is the link. We had this one called congruent supplements. That said if 2 angles are supplements to the same angle, then they're congruent to each other. And we are done with that. All right, in this video, I'm going to keep doing the last 2 pages, 87 and 88. So just you can stop watching the video, you can keep watching it, you can do the work on your own. So this one already done. What'd they do? They subtracted 7x from both sides. and then they added 12 to both sides, and then they divided both sides by -4. Okay? Number 2, which property is given here? xy is equal to ab is equal to gh. Here's the link. AB is the link. Transitive. Go with transitive on that one. All right, sticking with it here. Looking at 3, A, B, C, D, E. Substitution property says I can sub something in. If AB is equal to 20, then I can put the 20 where the AB is. So I'm subbing out the 20 in the AB, putting the 20 in for AB. Symmetric, that's where you flip around the equal sign. Measure of angle 2 equals measure of angle 1. Flip the left and the right side. Addition property says I can add the same thing to both sides. So I'm adding EF to both sides. Well, I'm adding AB with EF, and I'm adding, CD with EF. Sorry for the page jump there. Distributive property is just that. Distribute this 5. 5 times x is 5x. And then 5 times 8 is 40. I see it's already got the x there. 5x plus 40 equals 2. Transitive, here's your link. Get rid of your link. So this would be measure of angle 1 equals measure of angle 3. So pause this video, slow it down if you need to, and you can get those problems done. All right, we go down to the next one. More properties. This one, nothing has changed. That's our good friend, the reflexive. I see 3 things here. JK, MN, and XY, and I see a link. Transitive. This one, letter C, the left and the right side flip. Symmetric. And letter D, you could argue reflexive or symmetric, because ZY and YZ are the same thing. They are flipping, but they're not flipping around the equal sign. So it's kind of either one of these. I'm not going to split hairs on that one. Reflexive or symmetric. All right, flip the page over. We've got some matching to do with our proof. So these reasons are not in the correct order. So they're not in order over here. We need to arrange them over on where they should go. So given. So we're going to take the given first. We're going to use up letter D here. Then it says those 2 angles are equal. That's because we have the word bisector and we fit the definition. So that's going to be A, definition of angle bisector. Now from 2 to 3, all that's switching is the squiggly to an equal sign. Definition of congruence. And we see definition of congruent angles. That's going to be letter F. Then number 4 replaces PQR with 2 smaller angles that add up to it. So that would be angle addition. That would be letter C. Statement 5 replaces this SQR with another PQS. But we were told in statement 3 that they were equal, so we can sub in a PQS wherever we have an SQR. So I just gave it away there. It's substitution property. Don't worry about all this property of equality stuff. It's G, substitution. And then from 5 to 6, they are, this one you could argue just definition of multiplication is what we used in the past. We only have B and E left. And it's not division. We do division last. That's F. They call it the distributive property. I will go with it. I like definition of multiplication better for this one. That's what I would rather put there for number 6. But since they didn't give us that choice, it is kind of like the reverse distributive property. All right, and then moving down to the bottom, we don't have a reason bank, but I think there's 2 givens, so this one's going to be kind of quick. So let's find our 2 givens. They use them up right away. These 2 angles add up to 180. Angle 1 is 62. Okay, so then you're substituting angle 1 out and putting 62 in. Substitution. And then you're just subtracting 62 from both sides. So subtraction. All right. Good luck on your test coming up this week. If you have any questions, make sure you communicate with me.